Right, section 24.4 talks about the basicity of substituted arylamines. First, I wanted to look at the difference between arylamines and alkylamines, because their pKa's really show why the basicity goes down for arylamines. Okay, so the pKa of this ion is 10.6. So basically this third hydrogen on the nitrogen, one of the hydrogens here, let's go like this. This basicity would be 10.6. Likewise for this one, this basicity would be 4.6. And then this one would be 5.3. And this one would be 0.5. So let's go this way. Alright, right here. The reason why this one is far less basic than this one is if you look down here, when it loses its hydrogen right here and it becomes into a neutral state, it has 5 resident structures. So how you do that is you go like this. Alright, there. And then here, you would go like this. Sorry, right here. Actually, I left that out. You wouldn't have this, and it would be positive. And here you would do the same thing. Move that to there, and so you would move the charge over. Continue moving the charges. Oops. Sorry, that was supposed to be there. Still positive, minus, and you end up like that. So basically, the 5 resonance structures make this nitrogen far less likely that it wants to gain a hydrogen because of the resonance stabilization throughout the whole molecule. On this one, it's just bonded to a methyl group, which doesn't really have any pull in more, this one wins in the electron, that negative energy. So it actually holds more of the energy. So basically, we've concluded that nitrogen likes to be, well, nitrogen won't won't take a hydrogen, and like I said, give up this hydrogen when it's here. And also, much of the this resonance stabilization is lost on protonation, and it's a far bigger energy loss when you go in an arylamine versus an alkylamine. As a result, arylamines are less basic. So, more than one substituent on arylamine can be, it just depends on so if we have para-substituted arylamine, and we can just say this is why. This goes back to section 16.4, substituent effects on the aromatic ring. So it all depends on the substituent. If it's delocalizing or an electron deactivator, it will be less basic, and if it's electron donor, it will be more basic. So we'll go over to this chart, and this is strong base, and this will be a weak base. Alright, and these will be the Y's. So we've got the NH2, which is a strong electron donator, so more electrons going to go into the ring, which will make this side more basic, as well as this and a methyl group. So these are the activators, and then hydrogen's just kind of in there. He's mid-middle range. He doesn't really do anything. And then the deactivators are chlorine, bromine, cyanide, and NO2, because these actually take away, because their electromagnetic force is greater because they're in 7, at least the bromines, the halides are, and nitrogen's in 5. So it puts more into the ring. And then, so basically we figured out what would happen in a dye-substituted situation like para, but meta would be the same thing. It just, all depends on the basicity. And so overall, basicity of the substituted arylamines just depends on the substituent that's being added or is added already on it. So obviously it's NH2. And what would be added?